All right, I'm going to go through approximating areas under curves, and I'm going to go through the first rule, which is the trapezoidal rule. Now, you get this formula on your formula sheet, and when you get this formula on your formula sheet, it looks something like this. So they'll go the area under the curve. That's what that symbol is referring or asking you to do, between 2 points for any function equals, and it's an approximate because we're using an approximation, b minus a on 2, and then we'll have f of a plus 2 f of a plus b on 2 plus f of b. And I'm going to explain to you how this rule came about and then how you can use it. Now, this is for one application. This is one application of the trapezoidal rule. And they're going to use different words like intervals, subintervals, ordinates, and function values, which are all going to confuse you a little bit, but after a while you'll understand, or hopefully you will. So if we look over here, there's Archimedes, the great mathematician, who was very close to understanding calculus, which is doing things by infinite slicing. Now, he did work out pi, and other civilizations did as well, but the thing that he did that by doing a polygon inside and outside a circle and using lots and lots of sides to get a good approximation of pi. But one of the things he did was he worked out area around or inside curve shapes, and you can see here they've got a circle, by using infinite slicing. But even more so, he did volumes, and he was able to calculate the volume of a sphere to be exactly, get this, it's exactly 2/3 the volume of a cylinder that it fits inside, exactly in, which is quite brilliant, and that's what he wanted on his, as an epitaph. Now, so let's think about this. Here we've got this, so here we've got some sort of function. It doesn't matter what sort of function it is. And we're trying to find the area under the curve. Now, you can use rectangles, but as you can see, use rectangles, you get these gaps here. And that's if you use small rectangles. So you're a little bit less. If you use big rectangles, you get those gaps again, but the problem is you get a bigger area. So rectangles are good, and the more rectangles you use, the better your approximation. Hence, when we get to it later, you will understand when we do infinite slicing. A better form would be to use a trapezium. And as you can see here, this is a trapezium. And what you have are the two parallel sides. They're the two lines going up. And this is the important bit. Actually, I'll highlight it, but I'll highlight it in green. That bit there is your height. So if I were to draw this trapezium on its side, it would look like that. And you've got your B and your A, and that's going to be your perpendicular height, and these are your parallel sides. So your parallel sides are there and there. Now, you should remember from when you did area, that the area of a trapezium, and if I look back here at this formula, you watch this, the area of a trapezium is h on 2 and the parallel sides. And I'm going to use a capital A and B so as not to confuse them with the little a and b that we're using. But in the formula, you'll see it as little a plus b. That's a formula for the area of a trapezium. And what we have here, in this case, down here, is one trapezium. So how do we find the height? Well, here's the height. It's between A and B. And that's the perpendicular height, which is what we're looking for. So to find that, for example, if that was 3 and that was 1, the distance between them would be 3 minus 1. So you can see where they get the B minus A. And you can see why they put in the formula B minus A on 2. So if you know the height, you don't need to do the B minus A. So that's where the B minus A comes from, on 2. It's a height. Now using a trapezium, I need to find these values. This distance here, which I'll call, I don't know, M, and this distance here, which I'll call N. Actually, I should use the values that I wrote up there. That's big A and big B. And you'll notice on this diagram that that's this distance here and this distance here. And remember, we're using f of x. So to find the height, we just have to sub in whatever values are here. So A is going to be f of A. Whatever you put in, whatever that value is. Like, for example, here, if we indicated that it was 1, it would be f of 1 and whatever the function was. And this would be f of 3. But because it's b, and we're using algebra, we use f of little b. So, hence, we get our f of a and our f of b. Now, I'm going to talk about what the 2 times that is after I do an example question. So, here's an example. Here's the first question in the textbook. So if I go down here, I'm just getting my answers up. So we go down here to the first question. And it's y equals x squared. I'm just waiting for it to come up. So here we go, exercise 3.1. Y equals x squared between 2 and 1. Now my first and foremost thing you must always do, so it's exercise 3.1, is draw a diagram. And remember that that little squiggly line, which we're going to come across a bit later, it doesn't actually, in this case it means find the area. So we're finding the area, so this is question 1, between 2 and 1 of x squared using the trapezoidal rule. Now, the trapezoidal rule is h on 2, 1, 2, 1. That's how I want you to do it. So, I'm going to draw it. So here's y equals x squared. I could draw the rest of it there. And I need the area between 1 and 2. And remember, this is y equals x squared. Now remember, the height is this distance here. Well, that's pretty easy. The height is 1 unit. Now, I've only got these 2 strips. I've only got this bit and this bit. How do I find that? Well, I need f of 1, so that's 1 squared. Because remember, f of x is x squared. And I need f of 2. Well, that's 2 squared. So I get a half, 1 plus 4, which is a half of 5, which is 2 1/2. And it's really easy. You're just using a trapezium. Now, questions 1, 2, 3, 4 all use one subinterval. Notice that. Look at the word, a subinterval. So that's just one strip, because they use the word strips here later on. And later on they might use function values and different things. We'll talk about them. I want to go now to 5. So here's question 5, because it does it two ways. So again, I've got to find the area between 3 and 1, x cubed dx, using the trapezoidal rule. But in A, I've got to use one subinterval. So first I'm going to draw it. Remember, it looks like that. And we're going between 1 and 3. And remember that this is y equals x cubed. So in 5a, with one subinterval, h on 2, 1, 2, 1. And don't worry about the 2 yet. You'll see where that comes into play in a minute. So what's the height? Well, the height, remember the height is this distance here. And it's 2 units. You can go 3 minus 1 and get 2. So it's 2 on 2. And then I've got to find the parallel sides. So that's that one and that one. Well, that's pretty easy. That's 1 cubed plus 3 cubed. And we get 1 times 1 plus 27. So the area is 28. By the way, I should be putting units squared because I'm finding the units, the area. Now, in 5b, it says, use 2 strips. So I have to add another one there, which is going to give me 2. And now I'm using 2 strips to find the area. So I have to do 2 applications of the rule. Well, that's okay. 3 and 1, x cubed dx, using 2 trapezoidal rules. Well, that's h on 2, 1, 2, 1. And I have to do another one, h on 2, 1, 2, 1. Okay, well, the height now has changed because the height is that bit. And the height needs to be constant amongst all the strips. So the height is 1 over 2. And in this trapezium here, the first value is 1 cubed, and the second value is 2 cubed. That's okay. The height in the second one is exactly the same. It's 1. And the height of the first, or the length of the first one, is 2 cubed and 3 cubed. So what do we get? We get a half times 1 cubed is 1, 2 cubed is 8, plus a half, 2 cubed is 8, and 3 cubed is 27, which gives me a half times 9 plus a half times 35, which is the same as a half times 44, if I add the 9 and the 35 and factorise out the half, which gives me 22 units squared, which is a lot different from my 28 when I use 1 strip. Now, this one is much more accurate. In fact, the more strips you use, the more accurate you become. But I want to have a look, because I've been talking about using 1, 2, 1. And 1, 2, 1, why is that 2 there? Because when you use the trapezoidal rule, you don't have to do each one individually. You can do it all in one go. Watch this as I redo this question now, all in one go. So h on 2, 1, 2, 1. Well, the height is, for each of those strips, is 1. So it's 1 on 2. And then I've got the first one cubed, the first one of them, 1 cubed. And then I've got this 2. I'm going to go 2 times the next number. Oh, that's 2 cubed, the next function value. And then I've got 3 cubed is the last one. And if I do that, I get half times 44, which is 22. Now, why is that so? Because if you look in here, you've got a 2 cubed in that one, and you've got a 2 cubed in that one. So every time you do another one, the one on the end will get doubled because there'll be 2 of them each time, which is why you can do h on 2, 1, 2, 1. And it doesn't matter how many strips you do. So if I look at 13 now, and this is the last one I'm going to do, and then I expect you to do them. 13. Now 13, they haven't even given me what the function is. They've given me between 9 and 1, and they've given me these values. So I'm still going to draw it, 13. I'm still going to draw it because I want to get it clear in my head what I'm doing. And if I look at the values, right, on the x value, I've got 1, 3, 5, 7, 9. Yep. But on the y value, I start at 3, I go to 5, I go to 8, I go to 11, I go to 20. So the function is looking something like that. It's going up. And my first value is 1. Then I've got 3. Then I've got 5. And then I've got 7. And then I've got 9. So if I wanted to do this, I'd have to do 1, 2, 3, 4 trapezoidal rules. But because I've got the h on 2, 1, 2, 1, I can do it all in one go. So watch this. Here we go. The area between 9 and 1. Is it 9 and 1 or was it 7 and 1? No, 9 and 1. Of this function, whatever it is, and we don't know what the function is, using the trapezoidal rule and approximate h on 2, 1, 2, 1. Well, the height here is this distance between 3 and 1, and that's 2 units, so it's 2 on 2. That makes it easy because that's just going to be 1. And then I've got to do each of these values. Now they've given them to me in a table. There they are, 3.2, 5.9, 8.4, 11.6 and 20.1. So it's the first one, so 3.2 plus. Now look at it. This 3 is going to be part of this area and part of this area. So there's 2 of them. So 2 times the 3 value, which was 5.9. And this 5 is going to be part of the one there between 3 and 5, but also part of the one between 5 and 7. So there'll be 2 of them, and there'll be 2 7s. So just keep doing 2. So 2 times 5.9 plus 2 times 8.4. And remember, I'm getting these values from the table. Plus, I better have a look, double check because I can't remember what the next one was. 8.4, 11.6 and 20.1. So plus 2 times 11.6 plus, now the last value, it's only part of one strip. So it's just one of those, so plus 20.1. And then, and this line is critical. This whole thing here, this is critical because it's showing your substitutions. Then you put it all in your calculator, and remember it's an approximation, and when I did it I got 75.1 units. squared. And I reckon that remembering this formula in that version is much better. Okay, so what are the key points again? That we're using trapeziums to find the area. All right, we're using trapeziums. Here it is. You get the formula on the formula sheet, but it is only one application. All right, and you get given it in that form. I much prefer you to remember this form and make sure you show your substitutions. All right, good luck with the rest of the questions.